Okay, so this is DC circuits problem 6. So we have a circuit consisting of 5 resistors that are shown here, and the resistors are, 16, 85, 85, 62, 39, and the EMF of the battery is 8.5 volts. So the first question is asking, express the equivalent resistance of the combination of R2, R3, and R4. So since these resistors are in parallel, the resulting equation will look like this. And then for part B, the total resistance. Now the total resistance R1 and R5 are considered in series so that they're just added together normally. But since R2, R3, and R4, this whole thing is considered in series with R1 and R5. So you take the parallel resistor, the equivalent resistance, and you add it together with R1 and R5 to get your total resistance. And for part C, the total resistance is 80.22. For part D, it's asking for the express the current in terms of EMF and equivalent resistance. So voltage is equal to IR, I is equal to voltage over R, and voltage is just is in this case the EMF. So it's just current is equal to EMF over equivalent resistance. And now that answer to part E then is 0.106 amps. For part F, we're trying to find the power, the power lost through R1, or by R1, power lost by R1 through the current and the first resistors. So what we do is, we know that power is equal to voltage squared over R, which is also in turn EMF squared over R. And we also know that voltage is equal to IR, so current times resistance. So that means that power is equal to IR squared, since this is voltage squared, over R. Now, if we do a little bit of, like terms canceling out, we get I squared times R. So our new power is equal to current squared times R, or in this case, R1. And so for part G, calculate the numerical value. The numerical value, when plugged in, 0.106 squared times the first resistor, 16, that would equal 0.18 watts. So, yeah.